Welcome, this is another Cosmos. I'm going to take you through the exploratory data analysis for our parallel corpus, English to Uganda parallel corpus. As you can see here, we are trying to import the libraries. We are going to use like text blob, sklearn, NLK, NLTK, the natural language toolkit, and so many other libraries like word cloud. After the importation is done, we first read our parallel corpus using read CSV, which is a pandas function for reading CSV. Then we take a quick view of the parallel corpus by calling the head function, which displays the first 5 by default. You can click this to maybe the first 10, but by default it displays the first 5. And see how the English word and then the corresponding Uganda word. Then we call the info to give us like a quick view of how the corpus is. You can see the first column, we have English. It has 200 non-null observations. Uganda has also 2,000 non-null observations. Here we try to first remove the stop words, and we see the words with the most frequency without the stop words. You can see people, government leaders. You can, this corpus was extracted from newspapers. Several newspapers getting the articles and then translating them to Uganda like that. That's why you see words like people, government, leaders, Uganda having being the most frequent words in the corpus. Then here we try to draw like a plot to show us the most frequent words in the corpus. You can see the people, government, district, police. Yeah, this helps you, especially if you're targeting a particular domain. You would want words of that domain to be more frequent. So it shows you how our corpus is still behind in terms of our project, which is leveraging machine translation for the medical domain, specifically African languages, English to Uganda. So this corpus is a bit lacking on few medical terms, so that's helpful, and we shall have to keep on adding more medical jargon and as we continue to view the frequency until we have more medical words. This one, this is an n-gram plot. N-gram plots show you continuous sequence of n words. Now, for example, here we are using 2. Here we are using 2. You can see in the it seems to stand out more as a sequence of they, should be, to be. We can increase this to 3 and we see what is they need to be. As you can see, you can increase this to what you want. You continue seeing the sequence, especially you're targeting a particular sequence. Now, the next bit of analysis is more of topic analysis, trying to see the most outstanding topics in the corpus and how similar they are, how related they are. That's so helpful, especially if you're targeting particular topics. You're targeting particular topics. As you can see, topic 1 and topic 3 are overlapping, which shows that they are quite related. And then 4 and 2 are far apart. And this one on the right shows you the frequency of words in that particular topic. Yeah. So, and the red part shows you out of the total how many of that particular word appears in that topic. As you can see, these two are quite related since they are overlapping. And we want more overlapping topics, but for the medical field, because everything has to be connected to make sense. Here we are going for a word cloud. The word cloud is helpful in showing still more of like the frequency, showing you the outstanding words in the corpus. As you see, people is outstanding, government, they like I say, this is usually good if you are targeting a particular domain and you would want to have words of that domain stand out. So having this word cloud will help us to, because we want this to be filled with a lot of medical instructions, because that's our target in our data collection. I mean, in our pre-processing process, we want to have more data and more outstanding words of the medical field, health instructions and prescriptions specifically. So this will be helpful. Here we are going for polarity, which is more of analyzing sentiments and seeing how positive and negative the words in the corpus are. As you see, this one shows you like a distribution. We have some positive words, but as we go, it seems we have more words that are neutral, and then some that are tending towards the negative. But our intention is to have these shift more this side, because we can't have words that are negative in medicine, because they can easily demoralize clients and patients. So it will be good for that. Analyzing quality is very good in showing you what you need, especially what speech you need to filter out. Here I tried to give you like a quick view of the positive ones. Specifically, you can say the positive ones. I did 8, maybe I can do 10 to make a lot to increase more on the positive. You can see we urged to welcome refugees in our camp. That seems a bit positive. It is legal to own a gun. It's a very positive sentence, as you can see. Then we try to look through the negatives. Let me also increase this to 10. You can see the border districts are insecure. That's quite a negative sentence. You can see. So clarity helps us to view such, especially if you want to filter out this, now you can head out and remove this observation. And that's what we shall try to do, to remove more negative statements from the corpus. Yeah, we try to show you like a distribution of, you can see the negatives are few, but we intend to decrease them to at least nearly 0. And then we tend to have more neutral tend towards positive as. Then here, since I'm going to perform some text classification, I try to add some synthetic data in terms of choices, the topics. Yeah, so I tried to use NumPy to add, I added 3 specifically: sports, entertainment, and politics. So I tried to view the corpus with the topics I've added and see just randomly. These were assigned randomly. This is the random assignment. You see, this was taken into sports. They are just, it's synthetic data generated just to help me out in text classification. As you can see, there is more there are more topics in entertainment. I mean, then there are more sentences in politics than sports. Yeah. So here I called a model called BRT, sentence transformer, to give me a vector representation of this as we are heading towards classification. So yeah, this is using the model, this model, to create vector transformations of our English words, since we are going to classify the text and make some prediction of whether this topic is in entertainment, whether it's in sports, stuff like that. So here we try to split the data into the testing and training data. As you can see, I used a ratio of 0.1 to 0.9. So the training data will be 0.9 and the testing data will be 0.1. Then I use the random forest classifier, which is an ensemble learning technique which combines results from several random forests. So with the max depth, which this is like a hyperparameter, so phi it's 9, and when we try to test the accuracy of our model, let's wait and see the results. First run this, then run this. Let's wait a bit. It's trying to classify. Yeah, you see the accuracy is very low. It's something like 0.37, but I'll try to increase, to tune my hyperparameter and see if it increases. I'll take this to something like 15 and see what happens. Let me try to load this again. So I'm trying to do some hyperparameter tuning to see if it increases my score or not. So let's wait for some few minutes. Remember, our initial score was 0.39. So we perform some hyperparameter tuning, increasing the max depth of the see, we try to do 20 and see something good. So you keep on tuning the hyperparameter until you get something like an optimal result. I see it has increased to 385. You can continue to play around with the hyperparameter until you get an optimal accuracy, but I know the reason for my low accuracy. The power corpus is quite small, just as 2,000 observations. Those are quite small, and part of it is that my data is synthetic, so there's a high chance that it's highly biased. And yeah, but the entire concept of hyperparameter tuning has been quite well demonstrated using the random forest classifier. Yeah, thank you for listening.